Hey everyone, this is Aaron, and I'm going to be going over number 8. I didn't get this one wrong, so I'm going to be doing an extension, but I first wanted to go over why B is the correct answer. So we know that we're looking for the transformation that yields the same x-intercepts, and we also know that the function has 3 x-intercepts. So what I did was I just wrote an equation that does have 3 x-intercepts. The equation is y equals x cubed minus 3x squared minus 4x plus 12. And as you can see, this graph does have 3 x-intercepts. So now I'm just going to go over how each transformation from each answer choice affects the graph. So the first answer choice, you're just adding 5 to the overall function. You can see that in box 3 here. So what this does to the graph is it just shifts it up 5 units. And so this obviously is incorrect because this graph only has 1 x-intercept as opposed to 3. So answer choice A is wrong. So in answer choice B, you're multiplying the entire function by 5. So what this does is it stretches the graph vertically by a factor of 5, and this doesn't end up changing the x-intercepts. So that is why answer choice B is the correct answer. And here, answer choice C, you're replacing x by x with x times 5, and what this does to the graph is it shrinks it horizontally by a factor of 5. So as you can see here, the x-intercepts are clearly different. So answer choice C would be incorrect. And lastly, for answer choice D, what you're doing is you're just replacing x with x minus 5. And what this does is it shifts the graph right by 5. So this clearly changes the x-intercepts as well. So answer choice B would be the correct answer. This one is answer choice B, since it doesn't change the x-intercepts. Now I'm just going to talk about how transformations tend to affect x-intercepts as well as y-intercepts in general. And I was fiddling around in Desmos, and through the process of trial and error, I basically found out that reflections over the x-axis and vertical dilations are the only transformations that don't affect the x-intercepts. So I'm just going to go over to a new graph here. This is the same function as before. I just cleaned it up a little bit. So in box 3, this equation represents the original function reflected over the x-axis. And as you can see here, the x-intercepts remain the same. And so, yeah, reflection over the x-axis doesn't change the x-intercepts. And also, any dilation, any vertical dilation won't change it either. So I'm just going to put brackets around the whole function here. And any vertical dilation, no matter what the coefficient is, won't change the x-intercepts. So if we make this 4, let's say, the x-intercepts remain the same. If we make it 7 or -2, any coefficient there will keep the x-intercepts the same. So yeah, vertical dilation and reflection over the x-axis doesn't change the x-intercepts. Now, what if we wanted to keep the y-intercept the same? So in this function, the y-intercept is at 12. Is at 0, 12. So I found out that reflections over the y-axis don't change the y-intercept. So I did a reflection over the y-axis here, and as you can see by this graph, it is flipped over the y-axis, but the x-intercept is still the same. And yeah. So reflection over the y-axis doesn't change this value. And also, any dilation on the horizontal doesn't change the y-intercepts either. So I'm going to show that here in this first box by just putting all the x values in parentheses and then dilating them. And so any factor, any coefficient, sorry, that we put in front of the x will keep the y-intercept the same. So if we make it 3x, let's say, as you can see here, the y-intercept remains the same. The graph is just, it has just shrunken horizontally. And so, yeah, dilation horizontally doesn't affect the y-intercepts. And this is just because, if you think about it logically, the y-intercept is at the point where x equals 0. So no matter what number we multiply by 0, it'll still yield 0. So the only thing that will end up mattering in the end is the 12 at the end here. So if x equals 0 and we multiply that by any number, it's still going to yield 12 for when x equals 0. And so this function, another important point is that any change that we make to this value 12 at the end here will result in a different y-intercept. That's why if we have a coefficient in front of the whole function, clearly the 12 is being negated if we distribute the negative sign. So from this graph, you would see that the y-intercept has changed, and this is true for if we had any coefficient here. So if we change that to, let's say, 3, the y-intercept would be all the way up here, and so clearly that changes the y-intercept. So yeah, that's how different transformations affect different intercepts.